Welcome to What's Best Forum's Masters and Makers interview series. If you have not subscribed to the channel already, please kindly do so. Today we are meeting Joe Lavrencik, founder of Critical Mass Systems. Joe, good morning there.
Hey, good morning, Ron. Nice to see you.
Nice to see you as well. Have you designed every one of the stand and filter and footer components yourself, or do you work with outside designers or consultants?
I designed them all. I've designed everyone from the beginning.
Who physically makes the parts for the stands and the shelves and the footers? Who physically makes them? Where are they actually fabricated?
Everything is fabricated in the United States. Nothing is brought in from any other country.
How do the stands and the shelves work?
The stands themselves work using the first law of thermodynamics. They're converting vibration to heat. We take it a step beyond that. We do lower natural frequency. That's very important. But we also focus on retaining high frequencies. Everyone knows you can overdamp a component, and we're very careful in our designs to make sure that we do not overdamp, because if we do that, you lose your bass extension, you lose your slam, the imaging is affected, the tonality is affected, all of the instruments will be affected. So we're very careful to keep all of the frequencies in balance.
For the stands, as a customer moves up the product line from Sato to Maxim to Olympus, how should the customer expect his or her sound of the system to be changing?
Well, what we're trying to accomplish, and I think we've been successful in all of those designs, is to continually lower the noise floor as you move up the product line. So what you'll notice is that the noise floor will lower, the musicality, the sense of the music will be retained, and it will be enhanced as you move upward, because we use certain techniques to make that happen as we move up the product line.
And when you say noise floor, are you referring to perceptible background noise of the inherent noise of the amplification of the components, or what noise floor are you referring to exactly?
Well, there's always discussion about an inherent noise inside of components, and I think what we're referring to, that people would understand more specifically, is noise that's introduced into the signal path by just the vibration and the environment in the listening room. Just to digress a little bit without getting too far into the weeds, loudspeakers create sound, of course. Sound is vibration. The vibration is everywhere. Sound is everywhere. So the vibration itself comes up through the floor. It can be in the rack itself. We know that they will resonate. We compensate for that. We know that the electronics will tend to resonate. We know that the circuitry will be affected by that resonance. So what we're trying to do is lower the noise floor, lower the noise that's being introduced into the component, so that the design of the component, the circuitry, is unaffected by the environment in which it is sitting.
Your products are very insightfully and carefully engineered, but what's wrong with using a conventional hardwood stand and wood shelves?
I have to be honest, I like wood, but the issues with it are that it resonates. So what people tend to forget, and I'll go back to loudspeakers. Loudspeakers produce vibration, and the vibration is everywhere. And what they tend to forget is that, you're buying electronics, and they are designed today, they're excellent. I mean, the design of electronics is spectacular. However, they're affected greatly by that which they are placed on. So if they're placed on, let's say, a wooden rack or home furnishings, for example, it will change the way the component works. It won't work the way it was designed to work. And what you'll hear is a collapse of the soundstage, or you'll get some sort of resonance. Maybe the vocals aren't clear. You get sibilance, or some sort of edge in cymbals or violins. You don't get the extension that you should get. That's not the electronics. That's not the loudspeakers, and that's not the wiring. That's the thing upon which the components are placed. because they feed that energy back into the component. And again, it degrades the circuitry and the signal path.
I assume this issue is most acute if the components are in the listening room, either between the loudspeakers or on the side wall. What if somebody puts his or her components in an adjacent room? Does that greatly relieve some of the concern about the noise issue?
It depends. It can reduce it. Does it eliminate it? Not, it won't eliminate it. If you can hear the music, that means that there's vibration present in that space. So it's a way to go at it, but if you're really into music and hearing it as you would hear it live, that quality of the musical instrument as you would hear it live, that won't quite get you there.
On your website, you say, quote, Center Stage 2M helps components reach their engineered potential in 3 ways. First, they mitigate vibration coming up from the surface of the floor below them. And third, they transfer entropy out of the component by draining this excess vibrational energy away in the form of heat. But doesn't a material like sorbethane mitigate vibration coming up from the floor and also convert vibration into heat?
Sorbethane will, and so will other materials. You need to be careful about the damping, how you damp the component itself. When we build our component feet, we spend a great deal of time making sure that the damping that comes into contact with the component is absolutely specifically, critically designed dimensionally. We've gotten to the point where we can change and do change the dimensions of the damping materials in thousandths and tens of thousandths of an inch. And you might ask, well, how can you do that? And the answer is you either find the tools or make the tools to do it. And that's what we've done. And what we found is if you can really dial in damping and you have the right materials at the same time, you can help that component get to its design potential. Sorbethane, for example, just going back to that, it's a fine material for damping, but it's not the perfect material for high-end audio in and of itself by itself. So it just can't do enough to help that component get to its design potential.
In that same part of the website, you say, second, they cancel out their own noise, referring to the components. What self-noise of the components are you referring to here?
Everything does something. That is absolutely positively true. So if you put something underneath a component, it may take a while, but you'll hear it. And what we do is we use materials that, of course, they make noise when vibration passes through them, but we can take that effect and mitigate it, eliminate. Well, I hate to use the word eliminate because that's an ultimate word, but we can really mitigate the impact of those materials such that they don't degrade the component's design potential. They don't get in the way of the signal that's going through that component and being passed to the next component.
If we cut one of the footers in half and looked at the cross section, what would we see?
It goes back to the genesis of the foot itself. It was designed from our Olympus rack. The Olympus rack is our ultimate, it's our masterwork. But it's very expensive. It's expensive because of the steps and the quality that's required to make it look the way it looks aesthetically and to have it perform at the level at which it performed. So I thought, I wonder if I could take those design elements and dimensionally miniaturize them. So the foot itself is made from the same materials essentially that our Olympus rack is made from, very much in the same sequence, but just miniaturized. And we use alloys of aluminum, titanium, tungsten, copper, and then very specific damping materials. So those are the same materials that are found in our most expensive equipment. So it may look like you could cut that in half and say, well, this looks very simple. It's not. It's not simple. It's rather specifically designed in a certain way. If you change the elements, you change everything. If we change the damping, for example, on the top of it and change it by thousandths of an inch, it can go from really great to really awful. So it's very specific. It has to be designed a specific way, and we keep the sequences the same way we sequence them in the racks, and we find that the outcome is just is really good.
The website refers to, quote, the Olympus Ultra produces the lowest noise floor in the industry. How do you measure the noise floor of a filter shelf?
I've been in this business a long time, and I make it a habit to go around and listen to the best rooms that I hope to find at any audio show or in audio stores. And what I think I hear is I can spot noise floor really easily. I know it's not the electronics, it's not the loudspeakers, it's not the cabling, it's not the electricity. It's the thing upon which the components are resting. And I can hear what that architecture is doing, and I can also hear, based upon the materials that they're using, the effect upon the component itself. So if I hear something that's causing an anomaly inside of in a system, I can trace it back to the materials that they're using or how they're sequenced, and so on and so forth. And ours, we just don't hear that. And that's all taken out before we go to market with it. We remove all of those anomalies. We were very hard to do that. So just comparatively speaking, I think the noise floor of what we're building is much lower. And it's not just the Olympus. I'd go farther to say the Maxim has a tremendously low noise floor, our Ultra Q and the new Ultra shelves. We really stepped at the designs to make them clearly audibly better than they were in the past.
So I understand that sorbethane can overdamp a component. What kinds of stands or materials do you believe can underdamp a component? For example, what if somebody had a stand made out of concrete blocks or a stand out of blocks of stainless steel? Can extreme mass loading itself achieve a damping effect?
To answer your question specifically, I've run through all the materials that you've mentioned. Not so much a concrete block. I mean, that's kind of, what we did when we were in college. But I find that the issues with other materials, and I'm not picking on any materials in particular, but let's say, for example, stainless steel, they tend to tip up the sound stage. They will cause compression and just anomalies in the high frequencies. Maybe you hear it in the vocals, cymbals, violins, instrumentation. You kind of have to turn it down. Maybe there's certain kinds of music you can't listen to. Sometimes, symphonic music, certain systems don't seem to be able to play those. That can be the materials in the rack itself. We don't use stainless steel. I've tried it many, many times. And I can't make that work. Perhaps other companies can. I can't make it work because I can't get the damping right at the top, on the top end. It seems like as we apply different damping materials to try to control, get everything back in balance, if you will, that we're taking some frequencies and maybe over damping them to compensate. And then if we back off that, then the anomalies come back. So I only use very specific materials, and it's on the website what we use, but I find that if I really vary from that, it just doesn't work for me. I can't get that sense of realism uh, that I want to achieve. I want to help achieve, because I believe that's in the electronics. The electronics can do it. Loudspeakers can do it. Turntables can do it. They've really evolved to the point where people who do what I do need to raise their game so that tremendous engineering and technology can come out of the loudspeakers in terms of hearing realism, real music.
You referred to anomalies with the stainless steel blocks, meaning a high frequency emphasis. Is that the anomaly you were implying?
Yes.
Some people, for example, put stainless steel slabs on top of blocks of wood. Is that a way perhaps to mitigate the high frequency emphasis of the stainless steel block itself? Is that the kind of thing you're talking about in terms of mixing materials?
To me, that just seems like it's so off the mark that I wouldn't even consider it. But that's me. That doesn't, I'm not speaking as if maybe someone else wants to spend a lot of time trying to make that work, but for me, it's just not there. It's not viable.
On your website about footers, you write, quote, "The total immersion effect can be described as a highly articulated acoustic sound field that extends from the back of the soundstage and sometimes wraps around the listener.
Yeah.
In a stereo system without CMS products, the sound envelops the listener, sound is bouncing all around. So what are you talking about exactly here?"
The fourth wall. There's a fourth wall, that we can talk about, which is the front wall of the loudspeakers. What we tend to hear in most systems as the sound is behind the loudspeakers.
Mm-hmm.
That doesn't need to be that way. If you can lower the noise floor low enough, without affecting the frequency balance, and you not only do you get that sense of realism, but you will get the perceived effect of that, let's say, vocalist being in this exactly the same space you're in, or if you like to look at it the other way, you're in exactly the same space they're in. So it's as if you're walking into the soundstage, or the soundstage is enveloping you, and you're actually at that event. There's a sense of emotional contact with the performer that is there and available to be experienced. But it takes a great deal of work and effort to, as I said, lower the noise floor without affecting the frequency balance, so that you can get that connection, and that connection occurs when you feel enveloped by the sound. Now that's not on every recording, because certain recordings aren't recorded that way. They're engineered in different ways for different effects. But on really good recordings where the engineers and the mic placement was designed to really capture the event, you can clearly hear it.
When I go to Walt Disney Concert Hall, I personally want to perceive the orchestra stage in front of me. I don't necessarily want to have the sensation of being center stage with the conductor.
I don't know that you're center stage with the conductor. If you were talking about the conductor standing in front of the orchestra and being enveloped by the sound, that's something only a conductor can experience.
When I go to the concert hall, I have the sensation that the orchestra is well in front of me and I'm in the audience. I don't have the sensation of having the soundstage pulled towards me.
Okay, then let's refer to it this way. In classical music, the orchestra itself will always be in front of you, in my experience. I've never heard it any other way. What you would hear in that type of a setup, and listening to that kind of music, you would hear a great deal more detail in terms of what each musician or the choirs of instruments are playing. The interplay between the different parts of the orchestra would be much more highlighted, not to the point that it would be distracting, but to the point where you can hear it if you want to hear it, or you can hear the whole if you want to hear it. The being immersed in the sense that I'm talking about is more in the personal sense of maybe live music, where I mean, let's face it, there's a difference between recorded music and live music, but in the recording itself, when it is recorded, the vocalist is immersed, the mic is immersed in the vocalist's voice, and that comes through the loudspeakers. So you get a different feeling in those types of recordings.
On the website, you write, quote, knocking down the wall that separates the listener from the musicians requires the electromechanical balance inside the components to reach an ultrafine point of equilibrium and to hold that equilibrium point. Mm-hmm. But when the music starts playing again in our stereos, isn't that equilibrium point, which has been established, suddenly upset when the music starts playing again?
Not my experience. I think it goes a little bit deeper than that. I've been in some discussion with a rather well-noted research institute talking about kind of discussing what I've been doing and how and what I suspect the effect is. Silver and copper are crystalline structures, and there's positive ions in those crystalline structures, and there's valence electrons that are kind of flowing. The signal is flowing as the valence electrons flow. So if the positive ions are resonating, vibrating, that's going to create minute amounts of heat, but it's going to disturb that flow of valence electrons through the signal path, and it generates heat, changes minutely the resistance, and that will have the effect of changing the way the resistors work, and that's going to affect the capacitors. So I think what's happening, and we're trying to get to the bottom of this on a really scientific, minute level, is that we're actually helping the signal move with the least amount of interference that's possible.
Well, I know there's a protocol that customers should follow for allowing the footers to settle over time. But once that equilibrium takes place, when the music starts playing again, is not that equilibrium suddenly upset and have to be reset somehow again?
I would say no. I can see why you would ask that question, because the loudspeakers weren't playing. They were playing. Now maybe we've shut the system off for a little bit, and now we're going to turn the system back on.
Right.
I think if you're turning your system off and on, there's going to be some electrical settling that has nothing to do with the feet and more to do with maybe the wiring and just the loudspeakers warming up, the electronics warming up. What is that? Usually there's 30-40 minutes or something like that in most systems that that it takes for them to really come back to life. That's pretty normal in every system, but I think the equilibrium that's been established remains. Now, if you pull the feet out and you let them, you play the system for an extended period of time, it'll go back to its original state of equilibrium. But once that equilibrium is reached, it tends to settle there and stay there because nothing changes really. I mean, the feet are there, that electromechanical equilibrium point has been established. It is there. Whether we turn the system on or off, as the components heat up and get back to their normal playing condition, I think that the effect is not noticeable, let's say.
On the website, you say about using CMS components, quote, the better your components, the better your results. Why would this be? Why would CMS components tend to have a greater positive effect on better components rather than on more modest components, which might not be as well built in the first place?
I think that what happens is really great components are just as negatively affected by vibration as modest components, as you would put it. So the amount of potential loss in terms of performance loss to what the component is capable of doing is very great with a really good component. If you take a really good component and you put it on a terrible stand, it's not going to sound good. It's going to sound terrible. So was it designed to sound that way? No, it wasn't designed to sound that way. There's a lot more upside potential in that component. You can take really great components, put them in a room with, not optimal, let's say, structures, furniture, and they're not going to sound good. I mean, there's a lot of times when you could say in a great system with great loudspeakers, my ears hurt, or, I turn it down, I just don't, this doesn't sound good, or this kind of music doesn't sound good on this system. So when you fix that, when you get things right, what you find is you can play any kind of music and it doesn't hurt your ears to turn it up. And you can listen at a normal listening level. And what I mean by normal is that level that is comfortable for you, that makes you feel like it's really happening right here, right now. That's what we're looking for. I think that's a good general statement for me to make, that's what we all really want. But in order to get that, it takes more than just great electronics. You have to go to that next level and think about the fact that loudspeakers generate vibration. Music is vibration. So that needs to be addressed.
Does the concept of voicing, steering a component to cause a certain sound, play any role in the design or development of your products?
If I did that, I'd be out of business. No. We have to be neutral. We have to be invisible, in the process.
What components do you have in your full audio system which you use for testing the products? What loudspeakers do you use? What related components?
I don't tell anybody that. My system to me is a workbench. I've used the same equipment for almost ever. And the reason I do that is I need to know that if there's a change, the change is a result of something that I've done. So I like to keep everything the same in the same way. The components are sensitive to any change. So if I change one little thing, I can hear it. And that helps me produce a really neutral product. So I don't like to tell people what I use because I don't think that's important. It's just not important. What's important is that that I hear any minute change that occurs in that system based on something that I've changed in one of my products.
What's going on in your research department? What's the next new product we should expect from CMS?
Well, I just recently redesigned everything. And we're starting to bring those out. They're all out and available right now, but we're starting to show those at shows. Right now, the latest thing I've done is I replaced a loudspeaker foot. We came up with a new design. I think it's terrific. It can be used, admittedly, it can be used on other components too. You can put it underneath anything in your system. But it was originally designed for loudspeakers, and we'll be bringing that to market. It's replacing, we have an LS, which stands for loudspeaker, LS component line, footer line. And we're slowly replacing each one of those with something that's much better. And we started at the bottom. The LS 0.8 is being replaced by a product that's now, we're going to call the LS 2.25.
Joe, this has been great. Thank you very kindly for taking the time.
Oh, thank you, Ron.